So guys, today we're going to talk about Poisson distribution here. So by watching this video, you'll be able to solve any question on Poisson distribution, which seems very difficult to most of the people. You just need to know the formula of it, which is E minus mu of x and x factorial. There are only two parameters here. One of them is mu and one of them is x here. So you need to know one thing here now. You will be given the value of mu and you have to find whole stuff there. You need to know mu is equal to np. Okay, this is how it works. N are the number of trials and p is the success value you have. So let's suppose you will be given many stuffs there out to solve out. Then how you are going to do that here? So take out your calculator here and just go onto the limit function here. Now this is the limit function. You just need to know about the formula here. The formula says e raised to the power minus mu here. So I'm gonna take e here. E will be by pressing shift and log. This is how e is gotten here. And you need to press here one more bracket and wait, one more bracket is here. So you need to have e raised to the power minus of something. So you just need to put here minus, nothing more. So you have put the minus here, and now wait, you have to take one stuff more here. You need to press shift. You have to press here log. You have to press shift, and you have to take log, not this log, this one. Where is the our yeah? Here it is. So now you need to take out the fraction here. Here's the fraction. So now you can do it here. You can write mu minus e. Where is e? Here it is. And you have to multiply it with any minus number. So just begin here and multiply it with mu per x. Now mu here is also something you don't know about. So you are going to take a block here which you're going to put here, which is like a block. So you're gonna have a bracket here as this, and you're gonna take its par is x here, so you're gonna take alpha and x is going to be like this. So now you need to be here on the denominator, and you have to write here x once more, which is going to be like this, and you have to take factorial here. Factorial is like here shift and this one, it's factorial. Now you have been with the formula on your calculator, the Poisson distribution. Now you have to take almost many values, such as we know at the most there are different type of stuff as I told you before. Let me go on that. Yeah, as you will be given at least 3 heads, at most 3 heads, at exactly least three words will be repeated every time you will be given a question of any distribution, especially binomial and Poisson there. So you need to know at least means like 3 and more. The more till 1 till the trial ends. Your trial are sometimes n is equal to 10, so you need to go from 3 to 10. Exactly 3 means only 3. At most means from 0 to 3, okay, to the specific value. So let's say we have this one. So you are called that you have been given wait, it's a multiply sign. You can put it either, or you can't, or you just don't need it, and you have to then go here. It's negative sign, so you can put here any value of x you want to. So that's what we have been given with the value of mu uh, as 9 here. Let's say mu is given us like 9, so we're gonna put 9 here, and it's like 9, and we have been told then you have to calculate at most. Now at most means from 0, so we're gonna put 0 on here. Here the value will be, that will be minimum, so it will be from where we need to go from. So we are gonna from 0, so we're gonna take it 0 up to I'm gonna say it like we have to go up to 9 is the mu value. Number of trials are, let's say, 10, so we have a given that at most 5, so we're gonna take 5 here. So let's calculate its value, which is going to be like So this is the value we have been with till 5 here. So this is our Poisson distribution here, and you have been known about it. So now we will talk about derivation of Poisson distribution from binomial distribution. Like why we are going to take it binomial to Poisson, what are the things that binomial can't describe which Poisson will describe us. So we will talk about this whole in this derivation. So we have mu is equal to np as we know. So we have to go from binomial to Python. So binomial formula is given us as np. As we know, two parameters are in binomial. One np, n means number of trials, and p means the success rate. And the formula of binomial is ncx p power x 1 minus p n minus x. And let we're gonna assume that n the number of trials we are performing are infinite, like there's so much and success rate is almost zero. That is the case, we will jump from binomial to Poisson distribution. So as you know, this is the formula for binomial here. So now we're gonna change it, like we're gonna simplify this ncx into its original term. Let's say the limit is being performed here is till infinite. I'm gonna say n factorial x factorial n minus x factorial. As we know the p value here, as we have been known, the p is equal to mu over n. So we're gonna put mu over n wherever the p is. Okay, so here is the mu over n over x. So 1 minus mu over n and minus x. So you have got till here. Now we're gonna move forward here. Now we're gonna open n factorial to cancel out n minus x factorial in the denominator. So we can write n minus 1, n minus 2, n minus 3 up to n minus x factorial. But the one term that comes first from n minus x factorial is n minus x minus 1 factorial. Not factorial though. The factorial will be at the last, and both these values will be written as they were. So we have written those as they are here. Just they are looking some smaller though. We're gonna cancel out n minus x and n minus x from the denominator and from the denominator, and we're gonna take common n from these all terms that are left here. So n over x will be taken as common. So here n 1 minus 1 over n, here will be 1 minus x minus 1 over n will be get common. And the first from the first term n x will be taken common, because that's some power of x we can take in it as common from it. So n will be taken as common, which will be doing what? As we know, this is mu over x and n over x. So we're gonna take it and mu over x as it is here, and n over x into the denominator, and this value as it was 1 minus mu over n by n minus x. So it will cancel out n over x by n over x, and all of the values will be as they are. So let's go. So we are now here. So by taking that stuff, so we will be performing limit n to infinite. Like we're gonna put n here as infinite. So we will be given here as, but here will be only one left because it's going to be like infinite. This will be like zero, and this will be like zero, yeah. And we will be hold these three values. These two values will become by putting n is equal to infinite as 1, and we will get 1 over x factorial from this term, and these two terms will be written as they are. So we are doing the same here, as this is like that, and these term are now the last term is now separated. There will 1 minus mu over n minus x. So we have written it two times, but one with n power and one with minus x term. So we know that by putting n this is whole is constant, these two values constant, we're taking them out, and these two are left. Now we're going to perform limit to infinite on them too. So we know this by performing here n to infinite, it will become the 1 raised to power minus x, or any power will be there. It will be 1, so it's 1. And by we know 1 minus mu over n is like what? It's like e minus mu. We know that. So we are going to take it here. And this is our formula for Poisson, which we had been done now, that how we can derive binomial Poisson from binomial. This is our whole derivation. Thank you.